Hey everyone, welcome back to AP Precalc. This is lesson 2.13. Let's get right into it. All right, so here's the bell ringer for day one. Pause the video if you haven't done this already, because I am about to go over the answer. So here we want to rewrite this logarithmic expression in a single logarithm with a log base 10. And so they all just have log without any base, which means the implied base is going to be 10 in this case. The first thing I'm going to do is I'm going to take this minus 2 and I'm going to rewrite it with a log base 10. And so 2 is log base 10 of 100, and then with that minus still out there, because 10 squared is 100. The next thing I'm going to do is take these numbers outside the 6 and the 3 and turn them into exponents. So we should get log and then 2x cubed, and this whole thing to the 6, plus log 5y squared, and this whole thing cubed, minus log z, minus log 100, minus log 5. Now what I want to do is combine everything into one big fraction. So what this should look like is log base 10, and then here we're going to have 2 to the 6, which using a calculator, I would give you a calculator for that level of math, is 64. Times x to the power of 18 times this, which is 5 cubed is 125, and then y squared, and then this cubed is 2 times 3, which is 6, all over, so it's minus log base z, so z is going to go in the denominator. Same with 100 and same with 5. Remember, these are both multiplied, so it's technically 500, not 105. Here, let's see what we can cancel out. We can cancel out, divide this by 5, and then get that. We could also divide this by 5 as well to get 20, and then this would be 5. We can also divide it by 5 again to get 1 and 4. And then we can also divide 64 by 4 to get 1 and 16. So this really, when you cancel everything out, should be log base 10. You don't have to write that 10 in there. And then we have 16 x to the power of 18, y to the power of 6 over just z by itself. And that should be our answer there. So that's a pretty long one. You won't see anything that level of computation, but it is good practice to work with. All right, so today we're going to be focusing on solving exponential and logarithmic equations. Today we're going to be focusing on exponential equations, and then the next lesson we will focus on logarithmic equations. So this is a 2-day lesson. On the AP Pre-Calc exam, you will have 4 FRQs. The fourth one will require you to solve various different types of logarithmic and potentially exponential equations without using a calculator. So this is a no calculator question. These are the directions that you'll always see. So determine the exact value of any expression that can be attained without a calculator. So they would expect you to make some simple simplifications. So if you see like log base 2, 8, they would expect you to convert that to the number 3. If you see 2x plus 3x, they would expect you to be able to combine like terms. Same thing with the same base as exponents using your exponent rules. This should be 5 to the power of 5. Here, if you have, just to put it up in open space, x to the 5th over x squared, they would expect you to simplify that to x cubed, and then ln 3 plus ln 5, this should be ln of 3 times 5, which is ln 15. One thing they wouldn't expect you to do is like convert that to a decimal, right? That's pretty hard to do without a calculator, so you can leave it like that. All right, so here are some of the exponent properties that we've talked about before last semester in lesson 2.4. So if you need a refresher, go watch that YouTube video lesson. The properties are pretty simple. If you're multiplying two terms with the same base, you can add the exponents together. Same thing if you're dividing terms with the same base, you just subtract the exponents. And then if you have like 2 cubed and this to the 5th, this would be 2 to the power of 3 times 5, and you multiply the exponents then. which would be like 2 to the 15th in this case. So simplifying exponential expressions is pretty easy. We're going to convert all the terms to the base that's asked for in the question. So sometimes you'll work with now problems that require you to simplify just exponential expressions. Then we want to use these three properties to help us simplify the exponents and then combine them into one big term. So you'll see what I mean in a second when we work through a few examples. So example 1, rewrite each expression in the form 5 to the power of ax plus b, where this could be like 5 to the power of 3x plus 2. It could be 5 to the power of 7x minus 1. It could be 5 to the power of 2x, where b is potentially 0, right? So these are all options to be our answer. And so this is typically going to be the form that you see it in. So let's work with this. The first one, this is just 5 to the power of 10. So in this case, a is 0 and b is 10. So that works. Here, 9 minus 2, this is 5 to the power of 7. This would be 5 to the power of 12 times 3, which is 36. Here, we are looking for a base of 5. So we see 25, and we almost want to rewrite 25 as 5 squared. And because we want that base of 5, that's really important. And then this is going to be 5 squared and then cubed. So 5 to the power of 2 times 3, or 6. So those should be our first 4 answers. Those were all with really nice integers. However, you can also do it with terms involving x, and that's what we see now. So here we have 5 to the power of, and then we can add the exponents. So 3x plus 4 plus 7x minus 1, which is 5 to the power of 10x plus 3. And that's our answer. And this is going to be what you'll probably see more of, where it's in the form of ax plus b there. Here we have 5 to the power of 2x plus 9 minus, and then this is really important, and where a lot of students will make mistakes, you will need to distribute that. So this is technically 5 to the power of 2x plus 9 minus 3x plus 1, not minus 1. So then we should get 5 to the power of negative x plus 10. And that should be our answer for F. Right? A lot of people will get 5 to the power of negative x plus 8, and that would be incorrect. So make sure you distribute that negative sign when you're subtracting. This is 5 to the power of 3 times 2x plus 1, which is 5 to the power of 6x plus 3, and that should be our answer. So remember, you want it in this form here, so you will need to distribute that 3 to both terms. And then we're going to rewrite 25 like we did in the first one as 5 squared. And this whole thing is still to the power of 3x plus 1. So we didn't get or throw out that exponent. It's still there. And then this is 5 to the power of 2 times 3x plus 1, which is 5 to the power of 6x plus 2. So those would be our 8 answers there. All right, here we have a few more tricky ones, so let's try these. This is 5 to the power of 3x times 5 squared over 5 to the power of 6. So this is 5 to the power of 3x plus 2 over 5 to the power of 6, which is, whoops, not base 3. 5 to the power of 3x plus 2 minus 6, which is 5 to the power of 3x minus 4. And you don't have to show every single step. I would like to see some work. I don't want to just see the answer. It would technically be marked wrong on an exam or on the AP exam. So be careful of that. But that's me showing every single step is not needed to get full credit. So just show some of your steps. I don't just want to see you go straight to your answer. All right, B. 5 to the power of 4x minus 1 over 5 squared and then squared. This is still 4x minus 1 over 5 to the 4th, which is 5 to the power of 4x minus 1 minus 4, which is 5 to the power of 4x minus 5. And so that should be our answer there for B. For part C, we have 5 cubed over 5 to the power of 6x minus 1, which is 5 cubed, or 5, to the power of 3 minus 6x minus 1. Remember to distribute that negative sign. So this is 5 to the power of 3 minus 6x plus 1. And then to the power of negative 6x, and then 3 plus 1 is 4. And that should be your answer. Remember, it's okay if you have the terms like the x and the constant terms switched, but that's how I would like it, is ax plus b there. And then this one here, we have 5 to the power of 3x times 5 to the power of negative 2 minus 7, all over the square root of 5, which is 5 to the power of 1/2. Simplifying this is 5 to the power of x minus 7 over 5 to the power of 1/2, which is 5 to the power of x, and then minus 7 minus 1/2 is minus 7.5, which is either 15 over 2, or you could have 5 to the power of x minus 7.5. Either one of these would be okay if you have a fraction or a decimal form there. All right, so example 3 is going to be the form that you'll kind of see on your quizzes, tests, and AP exam, where I will give you a function like this and ask you to rewrite it in the form a base to the power of ax plus b, where a and b are constants. So let's practice here. Here we have 5 to the power of 4x times 25, which is 5 squared. So we want to get everything into a base of 5 from the question. And then the square root of 5 is 5 to the power of 1/2. This is going to be 5 to the power of 4x plus 2 over 5 to the 1/2, which is 5 to the power of 4x. And then 2 minus 1/2 is positive 3 over 2, or positive 1.5. So this, or I'm okay if you like decimals. Either one of these is good with me. All right. K, we want a base of 3. So sometimes you don't know, do I use base 9 or 3? You're going to want a base of 3 based on the question. So I'm going to rewrite 9 as 3 squared. And then this whole thing is still to the power of 2x plus 3 times 3 to the power of x plus 2 over 3 to the 1/2. This is 3 to the power of 4x plus 6 plus x plus 2 all over 3 to the 1/2, which is 3 to the power of 4x plus x is 5x. 6 plus 2 is 8, minus 1/2 is 7.5. So I'm going to do plus 15 over 2, or 7.5 there as our answer. Or if you want the decimal, that's fine too. All right, number 4. Pause the video now, try this one on your own, because I'm about to go over the answer. So here we have 4 to the power of x times 2 is just 2x times 4x plus 3, all over 4 to the 5th. This is a little easier. 4 to the power of 3x plus 3 over 4 to the 5th, which is 4 to the power of 3x, and then 3 minus 5 is minus 2. The next one, we're looking for a base of 3 again. This is 3 squared, and this whole thing is going to be to the power of x, and that whole thing is going to be cubed, times 3 over 3 to the 1/4. This is going to be 3 to the power of 2 times x times 3. 2 times 3 is 6, so this is just 6x times 3 to the power of, if it's just by itself, it's 1, and then 3 to the 1/4. So this should be 3 to the power of 6x, and then 1 minus 1/4 is just 3/4, so plus 3/4 there. And that should be our answer for example number 4. That's simplifying exponential equations. If you know how to do that and you're comfortable with that, then this should be pretty easy. This is just solving exponential equations. And so the strategies are pretty simple. You're going to want to convert every term to have a common base. They may not say what base in the question, so that's kind of for you to figure out. Typically, whatever base you see more of in the problem is going to be what you're going to want to convert to. Simplify anything you can using the rules, the power, product, and quotient property that we just learned with the exponent rules. Get all your x terms on the same side and then all your constant terms on the other side. And then if you have something like, let's say I have 2 to the power of x equals 2 to the power of 7. Here, because they're equal, the exponents have to be the same. We can infer that x equals 7. And so that's really what we're going to try to do with here. You may have to use logarithms and leave your answer in terms of logarithms, but we will come across that later. All right, example number 5. Solve the following exponential equations. Leave your answer in exact form, which means using logarithms, but we don't need to convert to decimals. So the first one here, we have 3 to the power of x equals 7. I'm just going to convert this into logarithmic form. So this is kind of what I mean. You're going to have log base 3 of x equals 7. And that's just converting it what we did in 2.9. And so that's going to be our answer for A. For B, the first thing we're going to want to do is get our constant terms on the same side. I'm going to leave our exponential term on the left side, so subtract 5, so 2x equals 6. And then I'm going to convert it to logarithmic form, so log base 2 of x equals 6, and that should be our answer for B. For C, I'm going to convert this to logarithmic form as well when you just see x in the exponent. So here we're going to have log base 5 of x minus 3 equals 9. And then we want to solve this equation just for x by itself, right? Not for x minus 3. So I'm going to add 3 to both sides. And so we should have 3 plus log base 5, 9 equals x, and that should be our answer there. Right, the next one, I'm going to add 2. So we have 5 to the power of x plus 1 equals 13. Once we have this, it's time to convert to logarithmic form. So log base 5 of x plus 1 equals 13. And then I'm just going to subtract 1, right? Do that inverse operation to get x equals log base 5, 13, and then that whole thing minus 1 there. So it's important to have the minus 1 separate because this is different than if I said my answer was that. Those are two different numbers, and so this would be marked wrong on an exam, so don't do that. You're going to want your answer clearly like this, where that -1 or that -1 is on the outside of that logarithm. Here, we're going to subtract 4 from both sides to get 7 power of x plus 3 equals 22. Turn it into logarithmic form, and then subtract 3. There we go. Here, I'm going to subtract 3 again. -10 equals -4 e to the x. I'm going to divide both sides by -4 to get 5 over 2 equals e to the x. And then I'm going to convert this to a logarithm form as well. So it's going to be ln, because it's going to be log base e of x is 5 over 2. And that's our answer here. Okay, so there are our 6 answers for example 5. You could see a problem like this on your quiz though. So be ready to solve these problems. All right, example number 6. This is where we have two terms with x on both sides of the equation. And so what we're going to want to do here is get basically the same base. So you have a number here to a power, let's say we'll call it x, equals a number to a power, we'll say 5 or something, right? And just a number something. And then we can set the exponents equal to each other and not have to worry about the bases as long as the bases are the same and they're equal to each other. So here, this is what I mean. We see two things with a base of 2. They're equal to each other. So we now know the exponents have to be equal. So now we can just solve this equation to find x. So I'm going to subtract 3x from both sides, or sorry, subtract 2x from both sides, and then add 1, and then solve by dividing both sides by 3. So x should be 8/3, should be our answer for the first one. This one, we're going to have to convert 8 with a base of 2. So I'm going to rewrite 8 as 2 cubed. There. Then this becomes 2 to the power of 9x minus 6. So remember to distribute that. And now we can set the exponents equal to each other because it's the same base. Subtract x from both sides. Add 6. And then divide by 8. And that should be our answer for B. For C, I'm going to take both of these and figure out what number is probably the best base here. In this case, it's actually going to be 3, right? We know 3 squared is 9, 3 cubed is 27, but like 9 squared is 81, so 9 doesn't really go into 27 perfectly. So 3 is going to be our best option here. And so I'm going to rewrite 9 as 3 squared. That's still to the power of 2x. Equals 3 cubed to the power of x plus 2. This is 3 to the power of 4x equals 3 to the power of 3x plus 6. Set the exponents equal to each other and subtract 3x to solve and get x equals 6 there. And then D, here, this is also tough to know what base to use. However, we are going to see, I see 1/2 and I see 4. Probably going to go with a base of 2 for this one. And so 1/2 is just 2 to the negative first. And then 4 is 2 squared. So remember to distribute 2 to the negative 5x minus 7 equals 2 to the 2x. And then set and solve. And that should be our answer, x equals -1. All right, example number 7. The function g is given by this function there. And so we're going to want to solve all of these equations. So let's do it one by one. Pause the video and try these for you on your own, because I'm about to go over the answers. So here we have e to the power of 1/2 x over e cubed equals e squared. This is e to the power of 1/2 x minus 3 equals e squared. And then we can set the exponents equal to each other and solve. And then here I'm going to multiply both sides by 2 to get x equals 10. So that should be our answer for number 1. Number 2, here I'm going to add e to both sides and then divide both sides by 8. And then e is just e to the first, so now we can set this equal to each other and solve to get x equals 1/3 there. The next one, we have 16 times 2 to the power of x over 3 equals 1. So I'm going to divide both sides by 16 first. So 2 to the power of x over 3 equals 1 over 16. And then I'm going to rewrite 1 over 16 as 2 to the power of, well, it's in the exponent. So it's going to be, or it's in the denominator, so it's going to be a negative exponent. And then 2 to the 4th is 16, so that should be 2 to the power of x over 3 equals 2 to the power of -4. And then set this equal and solve to get x equals -12 there. All right, 10, 11, and 12. Here we have 4 to the power of 2x plus x plus 3 over 4 to the 5th equals 4 to the 1/4. This is going to be 4 to the power of 3x, And then 3 minus 5 is minus 2 equals 4 to the 1/4. We can now set the exponents equal to each other. One thing I'm going to do here is when I see a fraction, I kind of like to get rid of it. So I'm going to multiply everything by 4. Now I'm going to add 8 to both sides and then divide by 12 to get x equals 9 over 12 is 3/4. And so that should be our answer for example number 10. Here, the only thing I'm going to do first is convert 4 to 2 squared. So 2 to the power of 3x times 2 squared to the power of x over 2 to the 5th equals 2 to the 1st. This is 2 to the power of 3x plus 2x over 2 to the power of 5, which is equal. So I'm just simplifying the left side first. 2 to the power of 5x minus 5, and then set it equal to 2 to the 1st. Set those equal. And that should be our answer, 6 over 5. The final one here, rewrite square root 5 as 5 to the power of 1/2. 25 should be 5 squared, this whole thing to the power of x, and then that whole thing squared, over 5 to the power of x minus 2, equals 1 over 5, which is 5 to the negative 1st. So the first thing I'm going to do is this left fraction is such a mess, I'm just going to simplify it before I even touch the right side of the fraction, or the right side of the equation. So this is going to be 5 to the power of 1/2 times 5 to the power of 2 times 2 is 4x over 5 to the power of x minus 2. This is going to be equal to 5 to the power of 4x minus x is 3x. And then 1/2 minus negative 2, though. Be careful because you're doing that. You have to like distribute this to both sides. So it should be plus 5 over 2 or plus 2.5 equals, and then 1 over 5 is 5 to the power of negative 1. So now we can set these exponents equal to each other. And then I'm going to subtract 2.5 from both sides. So negative 2 over 2 minus 5 over 2 is going to be negative 7 over 2. So 3x equals negative 7 over 2. And then to get rid of that 3, I'm going to divide both sides by 3 or multiply by 1/3 to get x equals negative 7 over 6. So that should be our answer for example number 12. All right, so now we are at day 2 of more fun. And so here we're going to be talking about solving logarithmic equations. So here's a bell ringer for today. Pause the video if you haven't done this yet, because I am about to go over the answers. So here we're going to convert everything into a base of 3. And so 3 is just 3 to the power of 2x times 9, which is 3 squared to the power of 4x minus 2, equals 27, which is going to be 3 cubed. Simplifying this, 3 to the power of, and then distribute, 8x minus 4 equals 3 cubed. 3 to the power of 10x minus 4 equals 3 cubed. And then here we have 10x minus 4 equals 3. And now we're just solving for x. So add 4 and then divide by 10. So x equals 7/10 or 0.7 should be our answer for the day 2 bell ringer. All right, so for day 2, we're going to be solving logarithmic equations. These properties of logarithms are ones that we talked about in 2.12. So if you're having trouble or forgot these, watch that video. I'm not going to spend a whole lot of time going over these because we just did this a few days ago, so hopefully you should know this. And then converting between exponential and logarithmic form, this is going to be pretty important. If we have I know in class we said a to the power of b equals c is equal to log base a of c equals b, or as long as you know like 5, let's say 5 squared is 25, right? In logarithmic form, this is going to be 5 of 25 equals 2, right? So example 13, just as kind of a warm up, don't use a calculator and evaluate each of the following logarithms. All right, so I'm just going to run through these answers here. I like to ask myself 3 to what power gets me 27? And that's going to be 3 cubed is 27. A lot of these are going to be either by formulas you should know, by properties of logarithms you should know, or just general computations you should know. Like you should know 3 cubed, hopefully by now is 27. 6 to what power is 36? That's 6 squared. 5 to what power is just 5 to the fourth? That's just going to be 4. This is a little tricky. E to what power gets you 1? Anything to the 0th power should be 1. 4 cubed is 64. 8 squared is 64. 9 to what power gets you 1/3? So we see it in the denominator, so it's probably going to be a negative number. And then we see 3 is the square root of 9, so it could be, or should be, negative 1/2. So that's going to be our answer for example number 7. Here we have e to what power is e to the power of root 5. That is just going to be root 5. This should be log base 327. 3 cubed is 27, so this is the same one as 1 to see if you're paying attention. Log 10 of 100, that's 10 squared is 100. 1/2 to what power gets you 16? So 1/2 here, if we raise this to a negative number, it's going to be flipping it. So we want 2 to the 4th is 16. So this is going to be raised to the power of negative 4. So that should be our answer for 11. And then 16, the square root of 16 is 6, or the square root, sorry, of 36 is 6. So 12 should be 1/2 there. All right, so when you have equations with only one logarithm, you want to isolate the log expression, on one side of the equation. And then you want to, step 2 is convert the equation to the alternate form. So if it's an exponential, you're going to want to convert it to logarithmic form. That way you can isolate x, that variable, and then just simply solve for the variable if necessary and simplify your answer when appropriate. So let's walk through a few examples here. Example number 14, we got 9 beautiful logarithmic equations, so let's try solving all of those there. Here, this is just going to be converting it to exponential. So 3 squared equals x. Here you should know x is 9, so that's our answer there. This is going to be 7 squared equals x minus 1. This is 49. And then add 1 to both sides to get x is 50. This is going to be e to the 4th equals 3x. So to solve for x, it's just going to be e to the 4th divided by 3. So that should be your answer for C. Take a note at like C, it's going to be a messy decimal, but because you won't have your calculator, you can just leave it like that. That's fine. Here, I'm going to divide both sides by 4 to get log base 2 of x equals 1. And then 2 to the 1st equals x. So that's just x equals 2. For e, I'm going to subtract 5. So log 8x equals 2. 8 squared equals x, so x equals 64 for e. This one is 3 log base 6, x minus 1 equals 6. Divide both sides by 3 first. And then 6 squared equals x minus 1. This is 36 plus 1 to add to both sides, so you should get x equals 37 there. Here, I'm going to subtract 4 and then multiply both sides by 5. So now we have ln 2 minus x equals 5. Then I'm going to convert this to exponential. So e to the 5th equals 2 minus x. I'm going to add x to both sides. and then subtract e to the fifth from both sides. And that should be our answer there. Then I'm going to subtract 4 for I. And then divide by 2. And then convert. So 3 cubed is 27 equals x plus 3. So subtract 3 from both sides. X equals 24. And then finally, I'm going to subtract 2 from both sides. So log base 5, 2x minus 1 equals 2. 5 squared is 25 equals 2x minus 1. 26 equals 2x. Divide both sides by 2. You should get x to be 13 there. All right, now we have 15 and 16. This is going to be how the questions are worded on your quiz, test, and exam. And so here you're given two equations. We want to solve when they're equal to each other. So basically just set both sides equal to each other and solve. So this is going to be log 10 4x equals negative 2. Then convert it to exponential. So 10 to the power of negative 2 equals 4x. Remember, this is 1 over 10 squared, which is just 1 over 100. So now that we have 4x equals 1 over 100, divide both sides by 4 to get x equals 1 over 400 as our answer. This next one here, we have log base 4 of 2x equals 3. And I'm going to convert this to exponential form. This is 64 equals 2x. And then you should get x equals 32. So that should be our answer for 16 there. Those are just equations with only one logarithm. And so when you're working with equations with multiple logarithms, you have to use your logarithmic properties to simplify different expressions before solving the equation. So you essentially want to get the logarithm down to one of two forms. Either log base, let's say 3 x equals 2, and then there you can convert it into exponential form and solve. Or you want to get it to log base 3x equals log base 3, 7, and then you can set the inside, the guts, equal to each other to say x equals 7. So those are the two forms you're going to want to solve by. What we just saw was we got a lot of form 1. However, with multiple logarithms, you're probably going to get something along the lines of form 2, but you could get form 1 from time to time. In either case, it is important to check for extraneous solutions. And so using log properties can sometimes lead to solutions that are not in the domain of the original equation. So remember, the biggest thing about logs is you cannot take the log of a negative number. That's a big no-no. Or you can't take the log of 0. So if you plug a number into a logarithm to like kind of test it back, kind of like a quadratic equation, and you get a negative number or you get 0 inside the parentheses inside the logarithm, then you're going to toss that solution out. We're going to see a few cases where that's the case. And then also just know the properties of logs. If you have log x plus log y equals log z, we cannot say x plus y equals z. Instead, you would want to combine this into log x times y equals log z, and you would be able to say xy equals z. That would be okay, but saying that them added together equals z would be wrong. So just be cautious of small mistakes like that. All right, number 17, let's work through all 4 of these, solve the following equations, check for extraneous solutions. And so for the first one here, I'm going to combine these by multiplying the insides together. So log, and then this is 3x plus 12. So when you're doing 3 times x plus 4, remember to distribute, equals log 5x minus 2. Set the insides equal to each other. Here, I'm going to subtract 3x and add 2 to get 14 equals 2x, and x equals 7. So that's going to be our answer for 1. Plugging it in, you would get 7 plus 4, which is 11. That's okay. 5 times 7 is 35, minus 2 is 33. That would be okay. So this is a good solution. The next one here, I'm going to then convert this to ln 7x plus 1 all over x minus 2 equals ln 10. And then set the insides equal to each other. So 7x plus 1 over x minus 2 equals 10. Multiply both sides by x minus 2. And then solve. So 21 equals 3x. Here, ironically enough, we get another x equals 7. Plugging it in, you would get 7 times 7, which is 49, plus 1, so that should be 50. That would be okay. And then 7 minus 2 is 5. That is okay as well. So all positive numbers, so this is a solution. For C, we have log base 3, and then this is going to be x plus 2 times x minus 3 equals log base 3 of 14. Here, let's simplify this first. So expanding this out or foiling, we are going to get x squared plus 2x minus 3x minus 6, which is x squared minus x minus 6 equals, and then we can take the insides here and just set it equal to 14. Then we can solve. So x squared minus x minus 20 equals 0. From here, we can factor to get x minus 5, x plus 4 equals 0. And then you get x equals 5 and x equals negative 4. Here, when you plug in 5 into this equation, 5 plus 2 is 7, 5 minus 3 is 2, all positive numbers, so this is a solution. If you plug in negative 4, though, this is the first time we're going to actually have to toss out a solution, because negative 4 plus 2, right, if we plug that in there, negative 4 plus 2 is negative 2. That's a negative number, so that's our first extraneous solution we have found. All right. The next one here, this is just ln of x over 3 equals 2. E squared equals x over 3. And then I'm going to multiply both sides by 3 to solve for x by itself. So 3e squared equals x. That should be our answer to part D there. All right, example number 18, solve the following equations, check for extraneous solutions when necessary. For this one, we want to first combine both these logarithms on the left-hand side. So this is going to be log base 4x minus log base 4 2 cubed, which is 8. This then will combine into log base 4 and then x over 8 equals log base 4 x plus 7. Now we are going to set these equal to each other, the insides, so x over 8 equals x plus 7. Multiply both sides by 8. You should get x equals 8x plus 56. Divide both sides by, or subtract 8x from both sides. Negative 7x equals 56. Divide both sides by 7x equals negative 8. And that should be our answer there. However, when we plug in negative 8 into these logarithms, you're going to get log base 4 of negative 8. That's not good. And you're going to get log base 4 of negative 8 plus 7, which is negative 1. And so this is not good as well. So actually, this would have no solution, because the solution we do get is extraneous. All right, the next one here, we're going to convert this to log x minus, and then 1, we need to put it in a log base 10. So remember, with no subscript, it's an implied 10. So 10 to the power of 1 is 10, minus or equals log x minus 18. Setting up this equation, log x over 10 equals log x minus 18. Setting the two insides equal to each other, x over 10 equals x minus 18. Then x equals 10x minus 180. Subtract 10x from both sides. Negative 9x equals negative 180. And then here, you should get x equals 20. This does work, so that is our solution for part B. Number 19 here, we have let ln x plus 15, and then we're subtracting ln x be equal to, or let that be f of x, and then g of x is this equation. Find where these intersect, so where this is equal to ln x plus 3, setting the insides equal to each other. Should get that, multiply both sides by x, and then set the left-hand side equal to 0, and then factor, and solve. Here we get x equals negative 5 and x equals positive 3. Positive 3 would be a solution. However, when you plug negative 5 in there, you get ln of negative 5, which you can't take the log of a negative number, so we're going to ditch that solution, and we should just be left with x equals 3. All right, number 20 and 21. Here we're going to combine both those logarithms, so we're setting these two equal to each other and solving. So this is going to be log base 3, and then 2x minus 3 times x plus 4 equals log base 3, 8x plus 2. Setting the insides equal to each other and foiling this out, remember, you have to distribute. This should be 2x squared plus 8x minus 3x, so plus 5x minus 12 equals 8x plus 2. Solving this equation, or setting it equal to 0, should get 2x squared minus 3x minus 14 equals 0. We know it's going to be 2x there, and then x here, it's going to have to be a plus and a minus that multiply to negative 14 and add to a negative 3. So let's see, probably negative 7 and then plus 2 times 2 is 4. So that's how you would factor this. 2x equals 7, x equals negative 2, and then x equals 7 over 2, and then negative 2. Negative 2 would produce negative solutions, especially here. So log base 3, 8 times negative 2 plus 2 is negative 16 plus 2. That's negative 14. That's no good. So we can throw out that solution. However, when x is positive, no matter what you plug it into, you should get positive solutions. So x equals 7 over 2 is going to be our answer there. 21, here we should get log base 3, x minus 5 over x plus 2 equals log base 3, 2. So set these two insides equal to each other. So x minus 5 equals, or over x plus 2 equals 2. So then x minus 5 equals 2 times x plus 2. This is x minus 5 equals 2x plus 4. Solving and setting this equal to 0, or solving for x, we're going to subtract x from both sides to get negative 5 equals x plus 4, and then subtract 4 to get negative 9 is equal to x. This is our only solution, which is extraneous, so this would also have no solution there. All right, and then finally, we're going to use or learn what I call the A method, and this is something that I came up with. The A method here is solving equations involving logarithmic or exponential functions that require a little bit of substitution. So what we are going to do is we are going to see an equation like this, right? Where you see 2 to the power of x, and that whole thing squared minus 5 times 2 to the power of x, and then we want to see where is this equal to 14. Setting this up, you are going to have 2 to the power of x squared minus 5 times 2 to the power of x equals 14. And this may seem pretty complicated to start, but we're going to make a replacement. We're going to substitute that 2 to the power of x with the letter a. And by doing that, now we have an equation that looks like a squared minus 5a equals 14. Doing this, we should end up typically with a quadratic equation, and now we're going to solve this by factoring and solving for a. So here we get a squared minus 5a minus 14 equals 0, a minus 7, a plus 2 equals 0. And so from this, you should get a equals 7 and a equals negative 2. Now, this is the most misstepped. A lot of people just stop here, and that would be wrong. You need to sub 2 to the power of x back in for a. Right? So that should be our answer. And then we want to solve for x. So here, converting this to a log, we should get log base 2 7 equals x. And then 2 to what power gets you negative 2? There's nothing where that would exist, because you would also get log base 2 negative 2 equals x, and you can't take the log of a negative number. So we're going to throw out this like possible solution. So this should be our only solution here. And that is going to be our answer for 22 there. All right, so 23, this is where we have a logarithmic function where we're going to require the a method. And you typically know it's going to be the a method by seeing something squared like that, where it's not typically solvable by other methods. So here we're going to set up log base 3x, and this whole thing is squared, plus log base 3x equals 6. And now we're going to sub log base 3x in for a. So this is a squared plus a equals 6. Solve this quadratic. A plus 3, a minus 2. And you should get a to be negative 3 and positive 2. Now, remember to sub it back in, this log back in. So log base 3 x equals negative 3, and log base 3 x equals 2. Convert this to exponential. So 3 to the power of negative 3 equals x. 3 squared equals x. This you should be able to do as well. So 3 to the power of negative 3 is 1 over 3 cubed, which is 1 over 27, is our first solution of x. And then here, 3 squared is just 9, is equal to x. Both of these would never produce a negative number inside the log, so both of these would be our solutions to example 23. Then finally, example 24. This was on the 2024 AP exam, and so only 10% got this question correct. And so what we want to do is, let's take a look here. We see an exponential function, e to the power of 2x minus e to the power of x minus 12. And we want to see, where does this equal 0? Now, usually you see, like in the last question, in example 22, we saw 2 to the power of x in parentheses squared, right? It was really nice and clear that it was in parentheses. This one, not so much. But this one, if we know the properties of exponents, right? A to the power of b, and then this to the power of c, is a to the power of b times c. And so e to the power of 2x is the same as e to the power of x, and this whole term squared. So it really is just like example 22, it's just a little bit more hidden. So let's rewrite this as e to the power of x squared minus e to the power of x minus 12 equals 0. And now let's make that substitution. Equals a. A squared minus a minus 12 equals 0. A minus 4, a plus 3. Then take your two solutions, which is a equals 4 and a equals negative 3, and sub e to the power of x back in. And so here, when you have, let's convert this to logarithmic form. So this is log base e of 4 equals x, or ln 4 is equal to x. That is our first answer. You can plug that in, no problem. Here, we would get e to the power, we would get log base e negative 3 equals x, or ln negative 3 equals x. However, you cannot take the log of a negative number. So we're going to throw out that solution. So this should be our only answer. And I was shocked that only 10% of students got this correct, but the key here is really seeing that e to the power of 2x is e to the power of x squared, and it's going to be one that requires the a method. All right, so if you have any questions, please come see me in office hours, and I will see you guys later. Thanks.